In this video lesson, we learn about the tangents to a circle. So here we have a circle, and now I'll explain what a tangent is first of all. A tangent is a line that intersects with a circle exactly at one point. So like these two lines I just drew are tangent lines to the circle. This line is not tangent because it intersects twice. So this is a tangent, intersects once, so is that line. But the third line I drew is not. It's actually called a secant, but that's for another lesson. So these tangents have some interesting special properties. Let's say we have a circle, and we have a tangent to some point on the circle. So here's the line, the tangent line. Then it has a special property that the radius of the circle that intersects it at that point on the circle is perpendicular. So as I drew, the tangent is perpendicular to the radius. And there are lots of other radii, but only one of them intersects the tangent line, and it is perpendicular. So once again, the tangent line and the radius intersecting it form a 90-degree angle. They are perpendicular. And this is actually a theorem. So now we're going to apply this principle to a few problems, because we know a lot of things about right triangles and about 90 degrees. Alright, so segment AB is tangent to the circle. We want to find AC, which I just marked, and it's x. So the radius is 8, so I can write all of these, connect all these points in the circle and label them with 8 because they're all radii, and it's perpendicular. And now we have this right triangle, ABO, and I'm redrawing it right here, just a little bit rotated. So this is ABO, and I'm relabeling these side lengths. And since it's a right triangle, we can apply the Pythagorean theorem. So first, I'm just going to solve for the entire length of AO, and I'm going to write that as y. Later on, we can solve for x from there. So by the Pythagorean theorem, y squared equals 8 squared plus 15 squared, which is equal to 64 plus 225, and that equals to, we add these together, we get 289, and to find y, we just take the square root, and y equals square root of 289, which is actually 17. So you could use a calculator for these, but in any case, you get that the entire length of AO is 17. But now we remember that AO is actually split into two parts, one of which is got length 8 because it's a radius, and the other part has length x because we want to find x. So x plus 8 equals 17, and we get x equals 17 minus 8 equals 9. So the length of segment AC is 9. Alright. We're ready for the next problem. Find the length of segment BC, which is tangent to both circles. So here we have BC. I'll label it as x, and it's tangent to both, so both of these radii are actually perpendicular. And another thing we know is that if we connect A and D, then it separates into the radius 5 and the radius 3. So now we have a lot of information, and we can transfer it away from the circles and rewrite it in its own little trapezoid, its own little four-sided figure. So here we have A, B, C, D. and I'm going to rewrite all the things we know about it. These two angles are perpendicular. We have 5, an x, a 3, and 5 plus 3 is 8. So now we're going to work with this figure, and we're going to try to find what x is. And the secret here is that if we draw a perpendicular from D to AB, like I just did, so you get a rectangle, and that means that we can transfer all the values because the opposite sides of the rectangle are equal. So we have x and x, and we have 3 and 3. And then we have a right triangle with legs x and 2 and hypotenuse 8. So we apply the Pythagorean theorem again. We get x squared equals 8 squared minus 2 squared. And that's 64 minus 4. And that's 60. So then to find x, we just have to take the square root of that. X squared equals 60, x equals square root of 60. And that is the square root of 4 times 15, which equals to 2, and then the 15 stays inside the square root. So 2 root 15. So that concludes this problem. The answer is 2 root 15. And here I'm just redrawing. What we applied was we made that little rectangle and used that to compute x. So thank you for watching this video lesson, and I hope it helped.